Okay, right. So as I said, on the Google Classroom, you should have a copy of all the questions that I'm going to go through with you today. So if you have got that available to you, that would be really useful so that you can annotate it. If not, you'll need to just sort of try and draw a quick sketch so that you can label the different parts of the diagram as we go through it. Okay, so we're going to do vector geometry today, which means hopefully you did the second lesson on vector geometry, so you've had a bit of an introduction to it and recognise some of the things that I'm going to be talking about, and then we'll move on and look at some of the more complicated parts of it. Just so that you're aware, it can appear on either exam paper, so it can be on either the non-calculator or the calculator, because you can't use a calculator for it anyway, so the calculator doesn't really help, but that means that they can put it on either just as something to do at that point. Okay, and the best way to solve some of the more complicated questions is just to think about what you can work out. So often, if they want to make it a grade 9 question, they can. All right, and that means it can be worth quite a few marks, but we're not necessarily always going to try and get full marks, but we're trying to pick up every mark we can, because it's those marks that are going to make a difference to your grade. So by just trying things with vector geometry, you can often pick up quite a few of the marks. All right, so just being prepared to give it a go. So on the previous lesson, hopefully you've seen the fact that we looked at vector notation. Okay, so when we're looking at vector notation, we describe a vector using 3 different methods. Okay, so that A to B with the arrow on top of it tells me the direction that we're traveling from A to B. We can write it in bold, which is often what you'll see in a textbook, and we underline it when we're writing it so that we know that we're using vectors rather than algebra. So in an exam, you would be expected to underline the vector so that they know you're talking about vectors at that point. It's more likely going to be bold when it's printed on your exam paper. Okay, but obviously, unless you're sitting there colouring over it to make it look really bold, which still doesn't necessarily always show up, you're better off just underlining it so it's clear. Okay, so we've got those 3 different methods there that we talked about previously, so you'll get used to seeing me as I'm working through the questions about underlining it, or if it's a typed one, it will be in bold. But realistically, this first one here is about helping us describe the journey. So this is what this notation is really useful for, so we can pick up marks and show the examiner that you know how to answer the questions. Right, here's the first question then that you've got on the sheet. So I'm just going to give you a couple of minutes to have a go at this one. Start off for me by just labelling as many things that you think are the same that would help you to try and answer the questions before you even look at what the questions are. Just try and label as much as you can on that diagram. All right, if you've got any questions, then please shout. And if you haven't already said hello in the chat box, please do so I know who we've got here. Thank you. Okay, give you another minute. If anyone's got any questions, please don't worry about asking them at this point. Right, are you ready for me to start going through this one? Okay, right, if we start off then, what I want you to do first is just to try and label things. So when I introduced vectors for you in the previous lesson, it's about kind of like a road network. That's what you kind of need to think of it. And we currently have two roads that have been built, okay? And the two roads that have been built are O to A because it's labelled with little a, and O to B because it's been labelled with little b. Okay, so at the moment they're the only two roads that we know that we can use. However, because the question has told us that we have two parallelograms in the diagram, so OBDE, okay, and OAFG, we know that these parallelograms here are the same. And you know with parallelograms that the two slanted sides are parallel to each other and the same size, so they are equal. And also the top and bottom will be parallel to each other and equal. So we can then try and annotate things. So because O to A is A, we know B to C is exactly the same size and same direction, so that's A, and the same for G to F. Okay, so we can label that piece of information on there just to help us in the first place. We can then go a step further and label all the other things. So because this bit's B, we know A to C will be B, and we know E to D will also be B. And again, because they told us B is the midpoint of OG, so this bit here is in the middle of this, then B to G must be the same length as well, and hence that's B, the one above it's B. So actually you can annotate almost every part of that diagram so that you've got something to work with. The only thing that should be blank now is D to F. Okay, has anyone got any questions at that point? Okay, so what we can do with it, now we've labelled everything there, so we've not earned any marks at this point, but this has given us quite a lot of information to work with so that we can give the questions a go. Okay, so part A wants us, in terms of A and B, work out the following vectors and give it in its simplest form. So the first one that we want to do is work out O to C. So that means getting from here over to here. So we've got a couple of choices in which way we want to travel. I've chosen to go from O to B and then from B to C. Remember, I can't just go through the middle of this because there's no road there. It doesn't exist. Okay, so I can't just randomly travel somewhere. I can only travel along the lines that I have and that I know. So we're going O to B and then B to C. Well, O to B is just B, and then B to C is just plus A. So it's B plus A or A plus B. It doesn't matter which way around you write it, it would be fully correct. Okay. If we have a look then at part 2, so this one wants us to work out how we get from B to A. So I'm starting here at B and I need to get over here to A. So again, I've got a couple of different ways. I could go up to C and along to A, or I could go along to O and up to A. It doesn't matter which one. I've chosen to go from B to O, and then I've chosen to go from O to A. So if I'm going from B to O, I'm going the wrong way down this road. So what would that one be? Anyone know what I'm doing at that point? So Callum's gone for the full answer. Callum, what is it just from B to O? That's it, Amelia's got it. So good, it's just negative B. So if you're going the wrong way down a road, you just change the sign of it. So it's positive B if I'm going from O to B, it's negative B when I'm going from B to O, and then I would add A to that, okay, which can be rewritten again as A minus B. Either way round is fully correct. Okay, we just tend to tidy it up a little bit as A minus B because of the negative, but it doesn't matter which way round you would get the marks at that point. Right, our next question then is D to F. So I'm up here at D and I want to get to F, and this is the one thing that I can't travel down because I know nothing about it at this point. So I have to find an alternative way. Now, technically, you can make it as complicated as you want to. Obviously, in an exam, you wouldn't necessarily want to, but there is nothing wrong with you going from D to E to A to C to F. That would work in just the same way as D to C to F does. Okay, but I'm going to go for the quickest because I'm less likely to make mistakes on that one. So going D to C and then C to F. So I'm going the wrong way down this one and then the right way along this one giving me negative a plus b or b minus a. Doesn't matter which way round. Okay, so hopefully you're all right with those. Those kind of questions then were the ones that you were kind of looking at in the previous lesson. And then we move on to the slightly more complicated part here, which is showing that EG and DF are parallel. And this is where it takes you to top end, sort of grade 8, grade 9. Okay, so this would be right at the back of the paper for you to do. So what we can do is label the fact that our answer there is B minus A, okay, or minus A plus B, as I said, doesn't matter. The next part then says show that EG and DF are parallel. So EG, okay, is going from here to here, so we need to figure out how we do that. And DF, which we've already worked out, okay, so we know that one. So if we go with starting off by working out E to G, E to G is going to be going from E to A, and then from A to O, and then from O to B, and B to G. Again, there are multiple ways of getting from E to G. You don't have to have gone that way. All right, when you simplify it at the end, you will always get the same answer, providing you've done it correctly. So you can go the long way or you can go a shorter way, as long as you get the final answer. So my E to A, I'm going negative A to O, take away A again, plus B, plus B. So I end up with that. And then just like with algebra, we need to tidy it up. So we simplify it as much as possible. And we end up with negative 2A plus 2B. All right, so hopefully you're all okay with that one. We then know that we want to prove it's parallel to DF. So if you remember back to the first and second lesson that you've hopefully done on vector geometry, to prove two vectors are parallel, they have to be exactly the same but a multiple of one another. Okay, so what we're trying to prove on this one is we know that D to F is B minus A because we worked that out in part 2. And we now know that E to G is 2 lots of B minus A. So if I rewrote this one the other way around and had 2B minus 2A, I can factorize the 2 outside to give me 2 lots of B minus A. And at that point, I just need to state, because it's a multiple of, or 2 lots of DF, the vectors are parallel, and I would get the marks. Okay, so I'm just going to leave that there for a minute so that you can write down anything you want to. And has anyone got any questions at this point? I know part B is quite complicated. All right, but I just want to show you some of these trickier questions so that you've seen them and had the opportunity to ask questions if you've got any. All right, does anyone need any longer? Okay. All right, we've got a few more that have signed in as well. So if anyone else still hasn't said hello in the chat box, that would be great. Okay, still need longer? All right, I will pop up the second question then. So this one's a little bit easier. Okay, so I'll give you a minute or two just to have a look at this one and see if you can figure out anything that you can work out at this point. Okay, give you another minute. And we'll start having a look together. Okay, if there's anybody else that's joined that hasn't said hello, please can you do so for me? So that I know who we've got. Right, are you ready then for me to start having a look at this one with you? Is there anyone that wants a little bit longer? Okay, right. If we have a look then, so D is the midpoint of BC. Okay, so we know up here that D is literally halfway between B and C. So that's what it means at that point. So that helps us. Okay. What we can do then is to use that to try and work out what we can. So if we're trying to find the pathway that we want to get from A to D, okay, which is over here and going over to here. All right, but remember there is no road built between the two here, so I've got to find an alternative way around. I'm going to go from A to B because I'm going to go up there, and then I'm going to go halfway along BC. Okay, which means because I need halfway along BC, I need to work out BC first. So that's going to be my first job. To get from B to C, remember the only roads that I can travel on at this point are for me to go from B to A and then from A to C. Okay, so to go from B to A, I'm going the wrong way down this one. So it's negative A, and the right way along this one, so plus B. Okay, which again, as we've said before, can be written as B minus A, so either of them. Now, in terms of trying to work out the actual answer to AD, I know AB is positive A, and then I want to go halfway along BC, which I've just worked out here, which is half of that vector. So I just put it in a bracket. And then I need to simplify that. So to do so, I need to expand the bracket. That's going to give me A, and then a half times negative A will give me negative a half A, and a half times B gives me plus a half B. And then if I simplify that, I've got A minus a half A, giving me a half A plus a half B. And I'm done. Okay, so I'll leave that there for a minute for you to take any notes that you want to. Has anyone got any questions at this point? So hopefully that one's just a little bit easier than the parallel proof type question. Any questions at all? Ready for me to move on? Oh, okay, I'll give you another minute. I will put the full PowerPoint up on the Google Classroom for you at the end of the lesson as well, so you have got it there if you do miss anything and you want to go back. Okay, we ready? Brilliant. Right, here's the next question. So this is a proper grade 9 question now. Okay, so this is as nasty as it can get from this point of view. So I'll give you a couple of minutes. Just think about what it is you can work out. Okay, you ready for me to start going through this one? Right, so we are told ABC is a triangle. X and Y are the midpoints of AB and AC respectively. So we know X is halfway between A and B, and Y is halfway between A and C at this point. We're told then that A to B, okay, is A. So the full length of A to B is A, and the full length of A to C is B. We're asked to prove that X and Y and B and C are parallel. All right, so in order to do this, we're thinking about what we did in that first question. So if we find XY, we need to prove that it is a multiple of BC. That shows that they've got exactly the same direction, and it's just one is potentially longer than the other one, but because they have the same direction, they would be parallel to each other. Okay, so that's what we are trying to do at this point. All right. Right, so I've got a request to slow down a little bit, so I'm happy to do that. That's fine. I'll give you a minute just to write that. So while you're thinking, what do you think you need to work out first? So to get your brains active, what do you need to do first, do you think, to try and start this question? Well done, Joe. We need to find B, C, and Amelia, we've got that. So your first job is to find B to C for me. So give that one a go. See if you can work that out for me. Perfect, we're on it. So to work out B to C, I'm going to start up at here. Remember, I can only go along the things that are labelled. So I need to go from B to A, and then from A to C. So I'm going the wrong way along that. So it's going to be negative A plus B. And you've got your first answer. So if you think about the question then, I've now worked out BC. What do I need to do now to pick up some marks? Anyone got any ideas? Think about the question. What's the bit in blue is really important. That's the part of the question that we're trying to answer. We've done something and got a mark. We're going to have to do something else, probably a bit harder, to get the rest of the marks. Good, well done, Kat. We need to work out x, y. Okay, so our starting point on this one is x to y. Now remember, x was the midpoint, so it's halfway along AB. So it's going to be a half A for this bit here and a half B for this bit here. So our starting point then, work out x, y. That then will give me negative a half A because we're still going the wrong way down it, plus a half B. So hopefully everybody's okay with that one. At that point then, remember we wanted to prove that they're parallel. So we need to show that they're a multiple of one another. So we need to factorize out something that helps us to compare the two. So the thing that they've both got in common, or they've got in common in x, y, is the half. So if we factorize the half outside of a bracket, we end up with xy being equal to a half of negative a plus b. And that tells us it's a half of BC, because we know BC was negative a plus b, and this is a half of negative a plus b. So we've shown that xy is actually equal to a half of BC. And because we've done that, it's a multiple of, even though it's a half, okay, it doesn't matter if it's not a whole number, it can be a fraction. They are the same in terms of direction, and hence they are parallel. And that would be a grade 9, probably a 4-mark question at that point. So that's how you would pick up the marks there. So I'll leave that there for a second so you can make any notes on that one. And if anyone's got any questions at this point, please feel free to ask. Okay. How do we know xy is half of BC? Okay, so Tom, we proved BC was negative a plus b here, so hopefully that bit you're okay with because we went the wrong way down there, negative a plus b. XY then, we said was half way along, so at negative a half a plus a half b, giving me this bit, which I then factorise out the half. Now I know the bit in the bracket, negative a plus b, is BC. So all I've done is replace that bracket there with the half BC here, and hence I can just state XY is half of BC. Is that all right, Tom? Good, cool. All right. Everyone finished with that question? Okay, right, next one. So proper exam question here. I'll give you a couple of minutes to have a look at this one. And then if you've got any questions in the meantime, please shout. And just think about the midpoint bits that it's talking about to help you. One more minute and then we'll have a look. If you're feeling confident with part one, you might want to start putting the answer in the chat box to see if who thinks they know how to do this bit already. For part one, OB. Good, couple of you trying it. Anybody else feeling brave? Right, so if we have a look at this first one together, OB then, I want to start down here at O. I could go along this way, but then I hit a dead end because I don't know that line and I don't know that line, so there's no way I can travel along those at the moment. So the only route that I can take is O to A plus A to B, so going straight up and then to the right, which means I'm going to do 2A plus 4B. So well done those of you that gave that one a try. So hopefully that's okay. Right, have a go then and see if you can think about AC for me. So see if anyone can figure out that one. A couple of you on it. Good then, so for the next one, I want to go from A to C. Again, the only way that I can travel on this one is down from A to O and then from O to C, so that's going to be my journey. I need to go the wrong way down this one, so it's going to be negative 2A plus 8B, and that can be written the other way around as well, so 8B minus 2A, so we've got quite a few of you getting that correct, lots of you writing it either way around, and again, either would be fully correct to pick up the marks. Right, the next question then is working out AE. So I'm going to give you another minute to see if you can figure out this one, see if anyone's got any ideas on what the answer for AE would be. Quite good at this, some of you. Okay, so we have a look. A to E, okay, means I want to travel along this bit. Now, what we're told in the question here is the point E is the midpoint of AC. So I know A to E is a half of this bit, and E to C is also a half of that bit. So I can label both those bits with a half to help me out. Okay, so I actually know A to E is a half of A to C. It's a half of that full length of the line. And we've just worked out A to C, so you don't need to do that again. We can just pop it in a bracket. So it's a half of 8b minus 2a. And then expand your brackets and you get 4b minus a or minus a plus 4b. Either is fully correct. So well done, those of you that have given that one a try. Right, part B then, so the tricky bit. We now need to show that ED and OC are parallel. What do I need to work out first? Good, 2 of you are on it. So ED, okay, so E is the one over here, getting to D. The only way I can do that, I think, at this point is to go up here, along here, and down here, which means we're going to have to use a whole range of information that we've previously worked out. Okay, so best route, I think, on this one to work out ED is to go from E to C, and then from C to D. Okay, as I said before, when some of the previous questions, there are multiple ways, so we could go up, along, and down. But that bit, if you think about it, I've got to go 1, 2, 3 parts of a journey. If I go E to C and C to D, I've only got to work out 2, so it's just making my life a little bit easier at that point. So E to C, we know E to C is exactly the same as A to E because they're both half of A to C. And then C to D is going to be half of CB. All right, so CB, we need to think about working that one out. What's CB going to be? What's my journey? If you can, in simplified form, what would it be to C to B? Good try, Amelia. I can see where you've got it from. So just think about what area you might have in yours. Think about which direction you're traveling in. Sam, you're close, but not quite. We're starting to get a couple of you getting that one. So let's go through it and just make sure everybody's okay. We've got then a half AC. So a half AC we worked out up here. So we just need to half that one, which gives me 4b minus 2a. Sorry, 4b minus a, because I've halved it, plus the half CB. But we do need to work out the CB first. So the CB is going to be going from C to O. So that's negative 8b, because we're going the wrong way down that one, plus 2a, plus my 4b. So that would be my journey. And then when I simplify that, I get 2a minus 4b or minus 4b plus 2a. So either way round again, fully correct. So that's where hopefully a couple of you can see where you went slightly wrong, but were very close to good effort for trying on that one. Okay, so at this point then I want to put that in to help me out working the next bit. So back to doing ED. I know it's my 4B take away A, and then I know it's half of what I've just worked out here. So the half of CB, and then I can expand that bracket, giving me 4B minus A plus a half of 2A gives me A, and a half of negative 4B gives me negative 2B. And then just like algebra, we need to simplify that down. So we've got negative A plus A. Well, that's going to disappear. It's going to cancel out. And 4B minus 2B leaves me with just 2B at that point. So I've worked out ED is worth 2B. So if we go back to the question, anyone got any ideas what I do now? So we're almost done. Anyone feeling brave? What bit are we missing? So for part B, think about what we've worked out. What's the only other bit that I need? Good. I've done ED, so the only other bit I need is OC. What is OC, Joe? Can you remember? What can you figure out? Oh, Harvey's in there already. Yeah, 8B. So I know OC is 8B. So if we think again in terms of why they're parallel to each other, can anyone remember the magic word that I'm looking for to prove that those two vectors are parallel to one another? Perfect, well done, Kat. It is a multiple. So OC is 4 lots of ED because 8B is 4 lots of 2B, and hence they're parallel because it is a multiple. Yeah, so can have the word scalar, but they will accept multiple on this one. So well done with that, Joe, as well. Okay, right, I'll leave that up there for a minute because there's quite a bit there for you to write down if you want to. As I said before at the start, with an exam question like this, it's going to be worth an awful lot of marks. It is very unlikely that you would get all 4 parts on an exam question because that's going to take you an awful long time. So they may just give you, out of the first 3, they may just give you 1 or 2 of them, but they will like part B. And part B, I would say, is probably a 5-mark question on its own there. And as much as as difficult as it is, what you just need to do is try and think about it wants you to work out these 2 things. So even just stating OC is 8B would get you a mark. And then trying to do anything to work out ED is going to help you pick up marks. So even if you get as far as saying it's EC plus CD, it's probably going to pick up a mark there. And then you've just got to try and figure out how to do it and break it down. So that's what the challenge is with vector geometry. It's not so much it's all complicated. It's figuring out how to start and then piecing things together to pick up the marks. Okay, I'll give you another minute on that one, just so you've had a chance to write down anything you want to. Has anyone got any questions at this point? Okay, are we ready for me to change the picture? Okay, I'll give you a minute. Yeah, that's fine. Are you ready, guys? Okay, right, next question then. And again, this is quite a complicated one as well. So when you do come to have a go at the questions for the last lesson of this week, which is based on this, it is more about doing the ratio stuff rather than the proving. So it's not quite as complicated as I'm going through with you today. So I've tried to pick the worst kind so that you've seen them, so you can ask if you want to at any point. Right, if you have a look at this one, think about what you know, what you can label, and anything that you could work out at this point for me. Right, I'm just going to get you started and then I'll let you think about some of the questions as we go through. So we know ABCD is a trapezium. So at that point, we know AB and DC are parallel to each other because we know that about a trapezium. And we can also tell it by the fact that AB is A and DC is 3A. So it's a multiple of, so that's proving our parallel theory. Okay. We then know that X is on AC such that A to X and X to C is 1 to 3. Okay, so technically there is a line that connects A to C, and then we're asked to work out AC, AX, BX, and XD, and then to figure out what it tells me about BX and D. So there's a lot going on there. Okay, it sounds quite complicated, so you need to break it down and do each part step by step. So the first thing we're going to do is just drawing AC and show roughly where we think X is. And then I want you to try and figure out those questions. So have a go first of all for me and figure out what AC is to start off with. Okay, anybody got AC? Good, got a few of you getting that one. So A to C then, we would work that out by going A to D and then D to C. So it's going to be B plus 3A, which we can keep like that. That's absolutely fine. Or we can write it the other way around as 3A plus B. Okay. Right, the next bit then I want you to think about is X is on the line AC such that this is one part along and this is 3 parts along. So how long is the whole line A to C? So how long is that whole line from A to C if you know this bit of information in the ratio? So what do you mean 3? Do you mean 3x, Callum, or 3 times? Good, we've got a couple of you spotting it there. Good. All right. Well done. So most of you have spotted this part's worth 1, this part's worth 3, so the whole line is therefore 4 long. So if I want just this bit, what fraction of it is A to X? Good, well done, girls. So we know A to X is a quarter of A to C. And we have just worked out A to C, so that helps us with that bit. So we know it's a quarter of what I've just worked out in the first question. And then I can expand that bracket. So I've got a quarter times 3A and a quarter times B, giving me 3/4 of A plus a quarter B. Now, it could be left in either format on this one. It would be perfectly fine to leave it like this if there was nothing else to simplify. But if you expand the brackets, then you get that one as well. So that's absolutely fine at that point. The next one I need to work out then is b to x. I'm going to give you a chance to give that one a go. So think about the journey you would be going on, and then what would your answer for b to x be? Good, we're starting there, but is there anything we can do with those answers, girls? So you're almost there. So if you're not sure, just to get you going, we would be going the wrong way then, down A to B or B to A. So the wrong way down there and then along that bit. Okay, so it's going to give me negative A plus 3/4 A plus 1/4 B, which we've got from here because that we know was AX. And then we just need to simplify it. Okay, so that's the bit that I think some of you have tried to avoid, shall we say. So we've got negative 1A plus 3/4 of A. So that's going to give me a negative 1/4 of A plus 1/4 of B. So well done, Marcus. I think you're the first one in there with a final simplified answer. So brilliant work on that one. Okay, right, your next job then is XD. See how far you can get with XD for me. Harvey, just see if you can simplify yours. And Jake, again, if you can simplify. But mostly we're getting the hang of it. I think Kitty was first in there with the correct answer, so well done. So XD means I'm going to go from X to A and then from A to D. Okay, so it's the wrong way down, A to X, which we worked out up here. So it's going to be the negative of all of that. So it's going to be negative 3/4 of A and negative 1/4 of B plus B. And then when we simplify that down, so we've got negative 3/4 of A and then negative 1/4 B plus B will give me 3/4 of B. And you've got that, and that's pretty tricky. Okay, so if you did manage to get that, then well done, because that is quite difficult, this question. Right, the last part then said, what does this tell you about B, X, and D? So that's what we need to think about now. So what do I know? What connects B, X, and D? Anyone see anything or any ideas at this point what they can tell me? Not sure. I'll pop up this bit of information. BX and D. We've worked out in the previous bit that BX was negative 1/4 A plus 1/4 B. And we worked out XD is negative 3/4 A and 3/4 B. What's the magic word I'm looking for? Good, they're multiples. What does the multiple tell me they are? Perfect. Okay, so if I factor out, this one has a common factor of a quarter, so it's a quarter of negative a plus b. This one's got a common factor of 3/4, so again 3/4 of negative a plus b, proving that they are multiples of each other and hence they are parallel. Now the bit that's new on this one is because we know these two, this line here, b to x, okay, and this line here, x to d, are parallel. We have two parallel lines, which if I can show you, we've got two parallel lines if you can see them like that. But because they're parallel and they both share that point x, they make a straight line. So that means technically the definition of that one is collinear. So if it makes a straight line, two parallel lines with a common point makes it collinear. So that's just a key word there that you've got on this one. Okay, anyone got any questions on that one? I've got one more question for us to go through and then hopefully you'll be well armed to be able to give the questions a go. Okay, would you like a bit longer to write that one down, or are you happy for me to move on? So the fractions, Tom, are you happy with the previous slide where we worked out bx and xd? Yeah, so all I've done on the previous, on this bit here, is write down what we had on the previous slide, and then I can see at this point that this a quarter here and there's a quarter here, so it's got a common factor of a quarter, which is why I put it on the outside of the bracket. And then I'm left with negative a and positive b. Are you happy with that bit? Good. And then the same with xd. So I've got, again, 3/4 in both, so I'm going to take the 3/4 out as my common factor, leaving me with negative a and positive b. So hence I've got the two pink things there are exactly the same thing, and hence I've got a quarter and 3/4. Well, 3/4 is 3 lots of that first one, and hence it's a multiple of. Is that okay, Tom? Yeah, cool. Everybody finished with this one? Yeah, okay. Right, last question. So on this one, we need to find the vector OB. We're told some information down the bottom, so we know AB is 2A and AO is 6B, so I would label those two things just to start off with. And then we know AP and PO is in the ratio of 2 to 1. So how long is the line AO? So yes, Tom, it is vector-wise 6b, but how long is that line? Thinking about this bit, the ratio information for me. So if A to P is 2 and P to O is 1, how long is the whole thing? Good, it's 3. Okay, so therefore, if the whole length of that line is 3, because we've got 3 parts to our ratio, what fraction of that line is AP? Good, well done, Sam. We know that that A to P is 2/3, and then P to O would be worth 1/3. So we can label that to help us. Right, now can you give it a go for me and work out OB to start off with? Good, most of you start to pick it up. Okay, so O to B, I'm going to go from O to A and then A to B. My O to A, I'm going the wrong way down this one, so negative 6B plus 2A, which again, some of you have written the other way around as well, so 2A minus 6B, and we're done. Okay, so we've got hopefully an easy mark on that one. Right, the next part of the question then wants us to show that Q is the midpoint of OB. So therefore, what fraction could I say here on that bit, O to Q, if I know that Q is the midpoint? Good, I can show that that bit is a half. And I also know that B is the midpoint of AC. So what fraction of AC is this bit here? Good, we got it again. So we can label all that information. So we know because it's a midpoint, it's half and half. And again, half and half on the bottom. And we need to show, so this is thinking about what we learnt on the last question, that PQC is a straight line. So to be able to do that, I want you to start off by working out PQ for me. Okay, so have a go at working out P to Q. So try and simplify it as much as possible. We got to. Just be careful with that one for me, Kat. So some of you need to be careful with your signs. All right. So we haven't seen the right answer yet. Give you a hint to get you going. P to Q is P to O, and then O to Q. So if you're not so confident, what's P to O? Good. P to O is a third of AP, so it's going to be a third of 6B, okay, giving me 2B. And then OQ, that's going to be a half of OB, and think you've already worked out OB in part A, so they did that on purpose. I'll give you that bit of information to help you. Then is there anyone that thinks they can get the final answer when it's simplified for me? Not quite, Jake, on that one. So if I put the next bit up, give you a hint. We know A to O is the 2B that we talked about a minute ago. O to B, we worked out up here as 2A minus 6B, and we only want to go from O to Q, so we only want half of that. So think about what that gives you. Excellent, well done, Bella. Okay, so at that point, if you expand your bracket, you've got 2B plus a half of 2A gives me A, and a half of negative 6B gives me minus 3B. And then we need to simplify, so we've got 2B minus 3B giving me negative B plus A, or A minus B. So either of them is fully correct. So we wanted to show PQC is a straight line. So we've worked out PQ. So the next thing we need to work out is the last part, which is QC. Okay, so can you have a go at QC for me? I'll give you a hint to get you started. think about, you should know something about QB already, just to help make life a little bit easier. So if we know QB, hopefully you've spotted that that's going to be the same as OQ, which is a half of OB, which you worked out on the previous bit there. So it's a half of OB plus BC. Half of OB was a half of what we worked out in part A again. Okay, the same as this bit here. And BC, because we know this was the midpoint, this was half of AC, we know this bit here between B and C is also 2A. So again, if we expand our brackets, we'll end up with A minus 3B and then add the 2A on the end, giving us 3A minus 3B. What have I proved at this point? What do I know about PQ and QC? Anyone spotted that magic word I'm looking for? Good, they're parallel. Why are they parallel? Again, what's the other magic word I'm looking for? Multiples, brilliant. Okay, so QC can be rewritten as 3 bracket A minus B, close bracket, and hence we can prove that QC is 3 lots of PQ, and as a result, Q and C are parallel, but again, because they've got this common point at Q, they form a straight line, or we can use the word collinear again. Okay. So again, I'll put that up. There's just one more slide where I'll just talk you through what the plan is for next week. And then if anyone's got any questions, I'll hang on for a bit. Okay, so remember you've got one more lesson of questions to practice, and these are focused mainly on doing the ratio part of the question rather than the collinear part. So I didn't want to leave you to be struggling with that on your own. It's something we can look at in a bit more detail when we're back in school in September, hopefully, on that one. But if you can be confident with using the ratios, that would be amazing at this point on your own at home. Okay. Would people like that slide left up a little bit longer? No, all happy? Okay, right. So next week then, you have your end of cycle assessment. So it's a 90-minute assessment that I need you to do. Ideally mark it as well before the live lesson. So the main focus of the live lesson next week will be being able to answer any questions that you have on that end of cycle assessment. So no offense, but if you haven't done the test, it's kind of pointless you coming along and then trying to do the test afterwards. All right, so you need to try and do that 90 minutes first. If you can let me know in advance any particular questions you want to go through, but you have got a Google form to fill in. So as long as that's filled in sort of by Wednesday evening, that at least gives me an idea of which particular questions lots of you have struggled with, and I will go through them in a little bit more detail for you. Okay, so if anyone's got any questions with any of the work that they've got so far, anything we've looked at today, or the end of a cycle assessment for next week, then please feel free to hang on and ask those questions now.